requires a multi-stage defense in-depth pipeline. Now, you need to understand that because of the autonomous part of this agent, you get to realize that you need to be very, very careful because this can become vulnerable. There's what we call prompt injection. Now, it means that somebody that can easily manipulate the agent in order to become to serve their malicious purposes. So because of that, you need to put the security in place. Because if you don't put the security in place, someone else could take advantage of the vulnerability and use it for his own or her own evil purpose. So we have the input validation, the execution arena, and the output. So you can put the security in during the input validation or execution phase or the output phase. So before the model, normalizing input validates intent against user's role and detect prompt injection or jailbreak attempt. And I'm going to tell you guys things about jailbreak. I hope I can be able to create a class to talk about some of these things in detail. Now, what happened is that when we talk about this prompt injection, it could happen during when they are developing this AI agents. You can put a hidden command. You can put a sort of a metadata or some sort of a prompt inside it and tell the AI that this is what you want it to do. And even when they deploy it and somebody takes it, the AI will now quickly start working against you. Now, for example, there was this guy I read some weeks back that created his own AI agent. What the AI agent was doing, it's in form of arts. So once you download that art, the moment you download the art will start crawling sensitive information like API keys and all that, a bank or ATM sensitive informations, because most times people use their systems to make payment and they save the card information on the system. So when you do that, it will quickly go and start crawling some of the sensitive information, and the guy can have access to all those things. Now, so you could inject it during development, and you could also perform prompt injection even on the AI itself during prompting. So during prompting, you can easily hide that sensitive information. You can put something and then the AI will not understand. It will lose guard, like Nigerians will say, and then it will be able to carry out in malicious purpose. Then when we talk about jailbreak, on the other hand, we're trying to make the AI to do what it's not designed to do. So we begin to tell the AI, for example, you see somebody come and said, and said, how would you advise someone that wants to go and rob a bank? Now, the person didn't say he wants to rob a bank, because if the person said he wants to rob a bank, immediately the AI is going to shut that person out and say, no, I cannot do this. So when the person comes and turn the prompt and say, how would you advise someone that wants to this? Or maybe it's something that has to do with biological weapon. Maybe the person wants to build a biological weapon that he can use it to harm people. Then the person comes and says, as someone is building this kind of things, how do you tell the person what to and what not to do? You see, it will trick the AI to give him that information, and then the AI will believe that it's not breaking the rule, but in real time, the person is actually trying to jailbreak it to reveal things to him that he can use it against others and do out for some malicious purposes that are not right. So during the model training, there's what we call the sandbox environment enforcing least privileges. It validates schema for tools, calling and preventing server-side request forgery. So the sandbox environment will help to be, looking at some of these schemas and the tools that are being called by this AI agent and see if some of these tools are not going to do the against the wish of how the AI was designed. Now, after the model, data loss prevention, block PII leakages, and groundedness check ensure the claims are supported by retrieved sources. So Of course, I always used to emphasize that you don't just take everything that the AI gives you and go into work entirely. You have to read the things that you get from these sources. You have to ensure the sources exist. You have to make sure that the AI result is not hallucinating. You have to make sure whatever you are giving out there is not just fabricated. But if you don't, you have to check and ensure that these things are safe, because the AI too make mistakes. And also sometimes, of course, it has inherent bias. Is there any question so far? Any question?
Not on my side yet.
Okay. So we have high risk action demand as two-step commit for tool safety. So of course we said whenever you are dealing with a high risk issue, then you need a two-step in order to ensure the tool safety. The first one is the active agent node. The second one is a human authorization gate. So this is where the human have to have the final saying before that particular thing will be, or that particular task will be executed. So that's why most times when you are interacting, and I don't know, we can do the practical side of the AI agent, but probably next time, you get to see that there is this thing I was using some time back. It was from Google to build apps. Once I give it what I want, it will produce sort of a blueprint of all the tasks that it's going to do and all the breakdown and everything. Then it will tell me I should review it and see if I'm okay with it. If not, I should ask it to go over it. So once I'm okay, I will now authorize it and say, yes, go ahead. Then it starts producing the final script. So that active agent, the agent send payload summary for review. So you take a look at that review and then you now authorize it. So most of the time, high risks that involve execute payment or delete a database, these are things that once it's been done, you cannot retrieve it. So it's better you leave the final authorization in the human hand, so the human approves and generates a time-bound cryptographic token. So never give an agent a long-lived master key. High-risk actions must require explicit human approval, returning a time-bound section scope token. This prevents the hallucinated action and provides a clear audit trails. So because you need to know at what point the AI started becoming rogue. So when you know when it started acting rogue, you can now be able to go back and fix what is actually happening. So the enterprise agent starts Unite Foundation model, orchestration and defense. So we always have at the first layer is the foundation model, which is the LLM, the vector base, the memory stores, the data grounding, the prompts and all that. They are all at this first foundation. At the second layer is where the logic begins to happen, where we looked at design pattern, the reflection loops, the interleaved, and the planning and the tool registry. Then at the top layer, we have the orchestration control. That's where the management stuff that I showed you guys earlier on sit. So there we have the framework, the state management, the roles, and the hierarchy. Then at the topmost is where we have the governance. And the governance is nothing but the defense in depth, the input validation, the two-step commit, and the DLP output filtering. So this is where the humans sit, and this is where they now have to oversee everything and ensure that what the AI is doing is the right thing. So continuous observability, observing, sorry, let me just put it observing. This is one of, and then auditability, sorry. Now, deploying the pipelines for predictability, deploy agents for adaptability. So again, when you want, there are situations where you don't need to use an AI agent, especially when you are thinking about things that has to do with prediction problem. when something is a prediction problem, it's always going to have sort of an input, and then this is the kind of output you are expecting. So that's kind of situation. You just need to train the AI model, and then the next thing you tell the AI model, this is what it's supposed to do. But then when you are looking at things that changes with time, something that is dynamic in nature, then you can always think about the AI agent to handle that area for you. So let's look at it. When to use an AI pipeline. The first rule is the execution part is known and fixed. Like I said, it has an input, it has an output. The trait, it requires explainable, reproducible decision, consistent outcome matter, and more than adaptive reasoning. So the fact that we now have AI agents does not mean that machine learning will fizzle away. No. So now machine learning is even going to become much more better because we will now be able to understand deeper why things are happening. So sometimes when you make those predictions, you begin to dig deeper into the AI to understand things like causation, association much, much better. Now, example of where you use an AI agentic pipelines is things on document classification, sentiment analysis, and fraud detection. It's better you give those AI because there's data and it's just for you to split it. But now, when to use agentic AI, when the path to the goal merges during execution. So it means that this is not something that you could easily say this is the end from the beginning, but the both of them are coexisting in one particular environment. So the goal and the executions are always interwoven. So that kind of situation is difficult for you to isolate them. In other words, because of the fact that these things are complex, they're not just relying on produce and output first, produce an input first, then an output, but rather you have both the input and outputs working concurrently. So that kind of situation, you need to bring in things like the AI agents to help you to automate it. Now, the trait, it requires reasoning through edge cases, dynamic tool use, and the ability to adapt to intermediate discovery. And that's where it becomes very crucial because of the adaptability. And this is where uncertainty is very high. And the good news is that this is how the real world operates, because in the real world, it is a world where uncertainty is very high. So because of the uncertainty, and the uncertainty, once it is high, you cannot use linearity to be able to approximate it. So you need a lot of complexity to understand it and also to be able to model it better. So that's how the real world works, and that's why the AI agents is quite used in the real world as well. So example, you want to sell qualification research, IT troubleshooting, autonomous data enrichment. So the AI agent does not replace traditional machine learning, it orchestrates it. It builds the system where the AI agent handles the uncertainty and the pipeline handles